I was watching a documentary called Edge of the Universe, and I guess season 1, episode 3, they attempt to describe the shape of the universe. So I was really shocked at how wrong they got it. I mean, this is supposed to be like a physics show, I guess. So I don't know if physicists everywhere in general, are this poor at picturing what the shape of the universe is like in 4 dimensions, but I at least hope that physicists aren't this bad at it. So, a good analogy would be if you were to take the Earth as the flat disk model, okay? And as a flat disk model, you have the North Pole in the center, and then the South Pole is basically the entire circumference is the South Pole. The entire circumference is touching the South Pole. And it's really a point, but it seems to be like the largest distance is the circumference, and it just appears that that point is just stretched out into a circumference. Okay, so similarly, when the universe is seen, like we look at the universe as this giant bubble from a 3D snapshot, we look at it as a giant bubble, but it's really a 4-dimensional space. And so what we do is we look at it the same way as we do this disk in relation to a 3D sphere. Well, this 4D bubble, we look at it as sort of like the same way. Some kind. It's the 4D bubble is like a disk. So how does this work? If we look at the cosmic microwave background radiation, what we're really doing is we're looking back in time. And really, the entire cosmic microwave background radiation is like the edge of Antarctica, where beyond that, the entire circumference of the universe, the entire that whole area is really just one point. And what is that point? That point is the Big Bang, right? Just like this disk model of the Earth is the South Pole is the circumference. So in the cosmic microwave background radiation, the beyond that is this location of the Big Bang, this time zero. So what we're really doing is when we're looking at the background radiation, we're looking at basically like the edge of Antarctica all around us. And yeah, so I mean, I guess it's more like the universe, you could look at it as if it's like the shape of this, more like a Hershey's Kiss or something from this model, or like a water drop or something, where like what you're doing really is when you're looking out, you're seeing the beginning of time, which is like this North Pole on this Hershey's Kiss, this little point. And what happens is the shape of the universe extends outwards and curves back in, and we're on this flat bottom part where the universe seems to be flat where we're from. But really what it's doing is it's curving backwards in time. It's curving backwards in time to a point where it's in a point where all of space is in a point and all of time is in a point, which is this tip of this Hershey's Kiss sort of thing. So this is really so the cosmic microwave background radiation. What we're generally seeing is we're looking on the outside of the sphere from the inside, right? But so it's this coastline of Antarctica. But what would really be interesting is if, and it wouldn't be too hard to do a computer algorithm. Excuse me. Excuse me. It wouldn't be too hard to do a computer algorithm where you take this outer sphere and you invert it. You turn it inside out, where it actually becomes where you can actually, it's like taking this outer ring of Antarctica and you turn it inside out, and then you get the shape of Antarctica, like the real shape of Antarctica. So you take this coastline that you see all around you, this coastline of the background radiation, and you turn it inside out, and what you get is this shape that's around the Big Bang at that time period. And that's basically it. That's basically what the shape of the universe is like. It's more like this Hershey's Kiss than it is And also they go into something like what's beyond the background radiation and more universes. And that's just really nonsensical. It's like what's beyond the South Pole? Well, you're going into the point of the South Pole, deeper and deeper in the point of the South Pole. Like what's beyond the South Pole and the disk model of the Earth? Well, you can't go beyond. That's like the whole circumference, right? If you go beyond it, you're actually going across the world. You're going the other way. You're coming out on the other side. So I mean, if you cross the Big Bang and you go to the other side, you'll end up on the other side of the universe at the time of the Big Bang, and then keep going, you'll eventually hit Earth again. It's the same sort of idea. But what's more interesting is when you look at matter versus antimatter. So there's this question, why is there more matter in the universe than there is antimatter? Well, that's the reason, because matter goes forwards in time. Antimatter goes backwards in time. So at time zero, at the time of the Big Bang, when there might have been at this time, there might have been an equal amount of matter and antimatter, but all the antimatter goes backwards in time. So it'll form this like opposing, this, I don't know, I guess it's going into the South Pole into the tip of the Hershey's Kiss in this model. But if you extend the model out to like the way we normally look at the universe, as like as time coming into a point, and space and time coming into a point, so really you have an anti direction where all the antimatter goes. It goes in the negative direction. So that's why we don't have it in our universe, because it's going the other way. But yeah, that's the shape. That's basic from our knowledge today. That's basically what we see as the shape of the universe. There's nothing like this video is just completely off base. So I just need to clear that up.